Hello everyone, welcome to your channel Sukh Academy EduWorld. I had already completed first 45 questions of chemistry prelims exam of Geo-Scientist 2024. You can check that videos in our channel. Otherwise, I'll also provide links for that in the description box. Today we will start from 46th question. In this question, they are asking that at a constant volume, the mean free path of gas is directly proportional to temperature, inversely proportional to pressure, directly proportional to both temperature and pressure, independent of temperature and pressure. Okay, so mean free path is the average distance traveled by a molecule between two successive collisions, and it is denoted by L, and the overall expression of the mean free path is KT divided by root 2 pi sigma square P. So ultimately mean free path is directly proportional to temperature and inversely proportional to pressure. Okay, so if pressure is constant, in that case mean free path will depend only on temperature. If temperature is constant, in that case mean free path will be dependent only pressure and varies inversely proportional. Yeah, so in this case, if volume is constant, so according to their question, and we have to check mean free path at constant volume. So if volume is kept constant, in that case, if volume is kept constant, in that case, according to Gay-Lussac's law, pressure will be directly proportional to temperature. So if volume is kept constant, in that case, pressure will be directly proportional to temperature. So ultimately, our first equation will become constant in the right side. Okay, so in that case, if volume is kept constant, mean free path will be independent of temperature and pressure both. So we have four options, and our correct option is in this question is D, that is independent of temperature and pressure if volume is kept constant. Okay, in the next question, hydrogen molecule with molar mass 2 gram per mole if used through a small hole at a temperature of 300 Kelvin and pressure of 5 torr. And under the same conditions, methane with molar mass 16 gram per mole is allowed to effuse. We have to find the ratio of the rate of fusion of hydrogen and methane. Okay. So, in the infusion, it involves the transfer of gaseous atoms or molecules from a container to a vacuum through a very small opening. Okay, so rate of effusion of a particular gas is inversely proportional to molecular mass of that gas. Okay. So in this case, we have two gases. One is hydrogen and other is methane. So rate of effusion, rate of effusion for hydrogen of hydrogen gas will be equal to its pressure, its molecular weight of hydrogen, and rate of effusion of methane gas will be inversely proportional to square root of methane. Okay, so we have to find the ratio of rate of fusion of hydrogen to methane. So in that case, we will divide 1 by 2. We will divide 1 by 2. So rate of effusion of hydrogen over rate of effusion of methane will be equal to 1 over mH2, 1 over molecular weight of methane. Okay, so ultimately we will be left with the square root of molecular weight of methane and molar mass of hydrogen. Okay, so now we will fill values into these, and molar mass of methane is 16. Okay, and for hydrogen it is 2. So we can write it as this. So we will left with root 8 ratio 1. So you can solve. Root 8 will be 2 root 2 over 1, and value of root 2 is 2 into 1.414 over 1. This is 2.828 over 1. So, sir, so our answer will be 2.828 ratio 1. This is the ratio of rate of diffusion of hydrogen to methane. Okay, so our correct answer in this question will be A. In the next question, they are asking that the work involved in a reversible adiabatic expansion. Reversible adiabatic expansion of an ideal gas from initial pressure Pi and initial volume Vi to Pf, that is final pressure and final volume, is given by. Okay. So in the case of reversible adiabatic expansion, reversible adiabatic expansion, they are saying that initial pressure is Pi and final pressure is Pf. Initial volume is Vi and final is Pf. In the reversible adiabatic expansion, the expression for the work done is nRT. This is final temperature minus initial temperature over gamma minus 1. Okay, so solve this expression, multiply nR. Okay, so we have, for the ideal gas, PV is equal to nRT. Okay, so this is for initial pressure Pi, Vi, nRTI, and for the final pressure it will be Pf, Vf, nRTF. Okay, so fill the value of nRTI and nRTF in this expression, in the equation 1. So work done will be, for the final condition, this will be Pf, Vf, Pi, Vi over gamma minus 1. Okay, so this is our one expression that is available in the options. Okay, so the correct option is first. Okay, so in the answer they are giving 4 options. Now we have to consider other cases also. There is one more expression for adiabatic processes. One is T1 over T2 power gamma is equal to P2 over P1 power 1 minus gamma. Okay. So in this case, first of all, take gamma in this side. It will be P1 over T2, P2 over P1, 1 minus gamma over gamma. Okay. So we know that gamma is equal to Cp over Cv. So we can fill its value here. Consider T1 over T2 will be P2 over P1, 1 over gamma minus 1, and fill its value here, 1 over Cp over Cv minus 1. This will be Cv minus Cp over Cp, and you know that Cp minus Cv is equal to R, and if we'll take minus common, then Cv minus Cp is equal to R, and Cv minus Cp will be equal to minus R. Okay, so fill the value here. So T1 over T2 will be equal to P2 over P1 power minus R over Cp. Clear? In the next case, since T1 we will replace it as with initial temperature and TF with T2 by final temperature. So this will be Ti over TF. T2 is final temperature, take TF here, and this is P1 is initial pressure minus R over Cp. Now consider value of Ti from this case. This will be equal to Ti Pi over Pf minus R over Cp is equal to Tm. Okay. So this value will be used. So this value we will use to find the final expression as they are providing in the options. So work done is equal to Nr over gamma minus 1 Tf minus Ti. So fill this value of Tf here. So work done will be Nr gamma minus 1 Pi over Pf minus R over Cp Ti minus Ti. Okay. Take Ti common. Nr Pi gamma minus 1 Pi over Pf minus R over Cp minus 1. Okay. And fill the value of gamma here also, that is Cp over Cv. Cp over Cv minus 1 minus R over Cp minus 1. Okay. So this will be NCV RTI Cp minus Cv okay, and you know Cp minus Cv is equal to R. Fill that value here. Okay, cut this R. So NCVT Pi over Pf minus R over Cp minus 1. Okay, now we can take minus 1 common. So this will be 1 minus Pi over Pf minus R over Cp. You can also make this term positive by taking just reverse Pf over Pi. This will be plus R over Cp. Okay. So this is the final expression that is provided in the option. So that option is maybe second. This is minus NCV Ti 1 minus Pf over Pi R over Cp. Okay. So second expression is also correct. Okay. And in this case, this is incorrect, and in this case they are providing here Cp. This is also incorrect. So our first and second expression is correct. So answer is A. In the 49th question, they are asking, consider the following variables: dielectric constant, surface tension, energy, enthalpy. Which one of the following regarding classification of variable? In this case, we have to provide which property is extensive and which is intensive. Extensive properties depends on the amount of substance, and intensive properties are independent of amount of substance. And in this case, first two options, one is dielectric constant and surface tension, both are intensive property, and energy and enthalpy both are extensive property. Okay, so according to that, our B option is correct in this question. So B is the answer of this question. Next question is, consider the following statements regarding compressibility factor. Statement 1 is, if a system at a state A is converted to state B by two methods, one method they are using reversible compression and other is irreversible compression. Okay, then the change in internal energy of the system is same in both the processes. This statement is false. This is incorrect statement. Okay, because they are using both different methods. One is reversible compression, one is irreversible compression. They are not mentioning here isothermal process. Okay, so both the processes are different, so that's why work done is also different in both the cases. And remaining heat is stored as an internal energy. So in this case, both the internal energy will be different. It depends on the work, and it depends also on the other conditions like temperature, heat, pressure, etc. So in both cases, internal energy will not be same, it will be different. So this statement is incorrect. In the second case, change in internal energy is a state function. This is correct statement. Internal energy is a state function. So first statement is false and second statement is correct. So D is the correct answer in this question. In the 51st question, in the next question, a 0.04 mole sample of monatomic gas at 1 atmospheric pressure and 298 Kelvin expands isothermally and reversibly from an initial volume 1 liter to 10 liter. It is then heated to 500 Kelvin followed by isothermal compression to 1 liter and finally cooled to 25 degrees Celsius, the internal energy for the overall process. So in this, they are treating the sample in three cases, in three stages. So in the first case, they are considering monoatomic gas. Monoatomic gas, okay. Pressure is 1 atmospheric pressure. Number of moles of gas 0.04. Temperature is 298 Kelvin. And this is in the first stage, the process is reversible isothermal expansion. Okay. And volume initial to final. And this is 1 liter and this is 10 liter. So this is the first stage of a gas. Okay. They expand the monatomic gas reversibly, okay, under isothermal condition. Now in the second stage, they are saying that at temperature 500 Kelvin, there is a process of isothermal compression. Okay, in this case, volume is again changes to 1 liter, okay, final volume to initial volume, and okay, in this case, this is the second stage. Okay, and finally they cooled the system at 25 degrees Celsius, meaning 273, and 273, that is 298 Kelvin. Okay, so they started the process. If temperature of the gas at the starting time, it is temperature at the initial temperature is 298 Kelvin, and the process occurs through different stages, first stage, second and third, and finally it reaches to a final stage. At that temperature is also 298 Kelvin. So in that case, change in the temperature is 0. Okay, change in the temperature 0. In the first stage, they are saying that system is isothermal. If system is isothermal, change in temperature should be 0. And you know internal energy is dependent only on temperature. So internal energy will be also equal to 0. In the second case, however, process is undergoes compression, but that is also under isothermal condition. And again, in this case, temperature is constant. Okay, and change in temperature will be zero. So again, internal energy is zero, and finally, system is at its initial stage. Okay, and temperature is the same. So overall, change in temperature is zero. Okay, and change in internal energy is zero because all the process is carried out under isothermal conditions. Okay, so temperature is constant and that's why internal energy will be zero. Okay, because change in temperature is zero. So in this question, the correct answer is C because initial stage is same as of a final. In the next question, consider the following statements. Statement 1 is the temperature of a perfect gas is unchanged by Joule-Thomson expansion. Okay, so Joule-Thomson effect is isothermic process, and for the Joule-Thomson, mu Jt is a Joule-Thomson coefficient. Okay, mu Jt is a Joule-Thomson coefficient that is equal to change in temperature with respect to change in pressure, and this is isothermic process. Okay, so in the case of Joule-Thomson effect, temperature decreases from initial to final temperature and pressure is also decreases. Okay, and gas started in the Joule-Thomson effect, temperature is decreased from high temperature to lower temperature as and because temperature is decreased, therefore kinetic energy will be decreased. But this occurs only in the case of real gases because in the real gases due to decrease in the kinetic energy of gaseous molecules, a part of this energy is used up in overcoming the van der Waals force of attractions existing between the molecules during expansion, but this is only for real gases. In the case of perfect gas, for ideal gas, there will be zero change in the temperature. Overall change in the temperature will be zero because there are almost negligible van der Waals forces in the ideal gases. So no expenditure of kinetic energy, so that's why change in the temperature is zero. If change in the temperature is zero, so in that case, in the ideal gas, uh, gas will be expand in vacuum and there is no absorption or evolution of heat. So that's why uh, mu Jt will be zero. Okay, so Joule-Thomson coefficient will be equal to zero in the case of a perfect gas. So this statement is correct. Now, in the second statement, for a perfect gas, Joule-Thomson coefficient is zero, as we are discussed. So, yeah, Joule-Thomson coefficient is zero in the case of perfect gases because no absorption nor evaluation of heat. So, heat is zero in the case of perfect gases. Okay, so no expenditure of energy in overcoming these force of these van der Waals forces during expansion. So both the statements are correct in this question. Okay, so both the statement are correct, true, and statement two is a correct explanation of statement one. Okay, so A is the correct answer in this question. In the 53rd question, in the free expansion process, the work done is zero and the heat transfer is zero. The work done is zero, but the heat flows into the system. The work is done by the system, but heat transfer is zero. The work is done on the system and heat flows out of the system. In these four options, the correct statement is A. In the case of free expansion, since work done is minus P external pressure into change in volume. Okay, this is the external pressure. Okay, and in the case of free expansion, external pressure is zero. If external pressure is zero, so work done will be zero and there will be no flow of heat in the system, so heat flow transfer will be zero. Okay, so its correct answer is A. In the case of next question, in the next question, Consider the following hypothetical reaction. One is this, and its value is change in enthalpy is A kilojoule per mole, and this is the second reaction. We have to find the change in enthalpy for overall reaction, that is this. Okay, so we have to obtain this value. So we have to obtain this reaction. For that, see, we take this equation as 1, take this is as 2, so subtract 1 minus 2. When we will subtract, take left side, this is the right side. Okay, this will be cancelled out with each other, so take xz in this case, so y plus xz. Okay, so this is the required reaction. Okay, so what we did, we just subtracted equation 2 from first and we found this reaction. So ultimately we have to also subtract both enthalpy values. So the for the first reaction enthalpy is A and for the second is B. So this is A minus B. Okay, so in this hypothetical reaction, change in the enthalpy of this reaction will be A minus B kilojoule per mole. Now, in the next question, the maximum efficiency of an engine operating between two temperatures, one is 127 degrees Celsius and other is 27 degrees Celsius. Okay, so in this case, we have to find efficiency. So, efficiency of the heat engine, that is denoted by eta, that is equal to 1 minus T1 over T2, and our T1 temperature is 27 degree. Okay, so convert it into Kelvin, that will be 300 Kelvin, and T2 temperature is 127 degrees Celsius, that will be 400 Kelvin. Fill these values here, so eta will be 1 minus 300 over 400. 100 over 400. So we have to find the efficiency in percentage. So multiply it with 100. So efficiency will be 25% of engine. So correct answer is B in this question. Now consider the following reaction. This, the value of change in enthalpy and Gibbs free energy minus 290 kilojoule and 230 kilojoule respectively at temperature T 300 Kelvin. What will be the value of change in Gibbs energy at 320 Kelvin, assuming that there is no variation in enthalpy and entropy with the temperature. Okay, so in this case, this is the reaction. So for first case, they are providing change in enthalpy minus 290 kilojoule, change in Gibbs energy minus 230 kilojoule, and change and temperature is 300 Kelvin. Take this temperature as T. Okay. In the second case, they are saying that delta H and delta S is the same. Okay, so we know the value of a change in enthalpy, but we don't have value of a change in entropy. So first of all, we will find this change in entropy. Then we will find Gibbs free energy. Okay, so delta G is equal to delta H minus T delta S. Okay, and this value is minus 230 and value of enthalpy is minus 290, temperature is 300 Kelvin, and change in entropy we have to find. Consider 290 in this side. This will be 60. Divide 300 by with 60. So change in entropy will be minus 1 over 5. Okay. Now we will use this value to find the change in Gibbs energy. Again, we will fill this value delta H minus T delta S. We will use this equation. They are saying that same value of delta H and delta S in this case. So we have to just change the temperature that they are providing. 320, value of entropy is minus 1 over 5, and value of enthalpy is minus 290. That is same. Okay, so now we will solve it. This will be 64 minus minus plus plus 64. Okay, this will be minus 226 kilojoule. So this is the final answer. Change in Gibbs energy minus 226 kilojoule. Okay. So in this question, our correct answer is C. In the next case, consider the following statements regarding change of enthalpy and change of entropy delta S for a chemical reaction at a given temperature. So first is, if delta H is negative, delta S is positive, reaction will be spontaneous. So Gibbs free energy is delta G is equal to delta H minus T delta S. Okay. So they are saying that enthalpy is negative. This is negative and this is positive. So reaction will be spontaneous. This statement is correct because for the to be the reaction spontaneous, enthalpy should be negative and always there should be increase in entropy. So this is correct statement. Okay. In the second case, they are saying that if delta H is positive and delta S is negative, and reaction will be spontaneous at low temperature. So if delta G is equal to delta T minus T into delta S, if delta H is positive and delta S is negative, so negative negative it will be plus. So ultimately delta H will be change in Gibbs energy will be greater than 0. So that is reaction will be non-spontaneous. So this statement is incorrect. Okay. Now in the third case, when both delta H and delta S, okay, enthalpy and entropy are positive, reaction will proceed spontaneously at high temperature. So take delta G is equal to delta H minus T delta S. If this is positive and this is also positive, okay, so they are saying that reaction will be spontaneous at high temperature. This is correct statement because if both terms are positive and if you will raise the temperature, obviously this term will increase. Okay, so if this will increase, ultimately delta G will become less than 0 and reaction will be spontaneous at high temperature. So both the first and third statement is correct. So our correct answer in this question is B. Now in the next question, consider the following reactions. Okay, they are providing for two reactions. One has change in enthalpy with negative sign and one has positive. Okay, which one of the following is correct with respect to above reaction? Uh, Reaction 1 is endothermic, 2 is exothermic, 2 is endothermic and 1 is exothermic and spontaneous at all temperatures. Okay. So we have to find that. But see, in the first case, reaction is exothermic. Okay. Because there is heat is releasing in this case, so reaction is exothermic. So first reaction is exothermic, and in the case there is a absorption of heat, so the second reaction is endothermic. In the first option they are saying that reaction is endothermic, so this is incorrect statement. In the second case they are saying that reaction second is exo, but reaction second is endothermic, so B statement is also incorrect. In the second is C part, they are saying that reaction second is endothermic. This is correct. Reaction first is exothermic. This is also correct. It means there are two probable answers. So now we have to discuss the remaining part, that is non-spontaneous at all temperature. They are saying that in the second reaction, that is endothermic, that will be non-spontaneous at all temperatures. Okay. So in this case, delta G is equal to delta H minus T delta S. For the second reaction, this is positive. Okay, delta H is positive here. And if we'll consider entropy, check the entropy in the reactant side, it has overall 3 over 2 number of moles. In this case, 1 number mole. In this case, 1 mole. So in this case, number of moles decreases. Number of moles decreases, it means entropy is decreases. Okay, if entropy is decreases, this is negative. So if this is a negative term, ultimately here will be positive sign. Okay, positive sign, minus and minus plus. So this will be delta H plus T delta S. Okay, so if you will increase the temperature, always reaction will get with the positive Gibbs free energy change. So value of delta G will be greater than 0. So reaction will be non-spontaneous at all temperature. So C statement is correct. Okay. So we have to provide one of the following correct statements. So C is our correct answer. Now we will discuss D part also. They are saying that this is exothermic, right? And we have to check its spontaneity. In the first case, delta G is delta H minus T delta S. For the first reaction, delta H is negative, and this is entropy is again in this case 3 over 2, and in this case number of moles are number of mole is 1. So ultimately entropy is negative in the case of first reaction. Okay, so this is also negative. So this is okay. So if we have to check that they are saying that spontaneous at all temperatures. So if you increase the temperature, this term will be increased. If this term will increase, then delta G will be greater than 0. And reaction will become non-spontaneous at higher temperature. But they are saying that spontaneous at all temperatures. So if you will increase the temperature, reaction will become non-spontaneous, not spontaneous. So D statement is incorrect. So correct answer of this question will be C. In the 59th question, the experimental results of colligative properties of solutions are often found to differ from the calculated values due to they are providing three options here. So colligative property helps us to find the calculate help us, so colligative property helps us to calculate the molecular masses of the solutes. But in some compounds, the molecular masses determined by these method don't agree with the expected values. Okay, so this discrepancy in the molecular masses is known as abnormal molecular masses, and that's why to get the exact value, solution should be dilute so that it become ideal, and solute must not undergo dissociation or association in the solution. And they are saying that uh, the experimental results of colligative property are often found to differ due to association and dissociation. This statement is correct. Okay, the solute must not undergo dissociation or association in the in the solution. So the association of the concerned solute and dissociation of the concerned solute both are correct option. In the third, they are saying the solutions being often non-ideal. Solution should be ideal, otherwise there will be discrepancy in the molecular masses. Okay, so solution should be dilute enough so that it behaves as an ideal solution. So C statement is also correct. So first, second, and third, both all the three statements are correct. So correct option is D. In the 60 question, the vapor pressure of pure water decreases from 24 torr to 23 torr on adding X amount of solute molar mass with molar mass 480 gram per mole in 150 gram of water. We have to find amount of the solute, that is X. Okay. So in this case, they are providing initial pressure 24 torr. Okay. And this is the final pressure, that is 23 torr. Okay. So you can take, this is the pressure of solution and this is the pure pressure of the water, P naught. Okay. X is the amount of solute. We will consider it W2. Okay. And molar mass of X, that is M2, is 480 gram per mole. Okay. I'm using 2 for solute and 1 number for solvent. Clear? Mass of solvent, our solvent is water, is 140 gram. We will consider it as W1. Okay. So to find the amount of the solute that they are considering it as X, we can take W2. So we will use this expression. Okay. So we have to find W2. We can also replace it by X because they are taking it X. Okay. So take X in one side. This will be, okay. So fill the values. This is molar mass of solute. W1 is weight of solvent. M1 is molar mass of solvent. And P naught is initial pressure of the solvent. And PS is pressure of the solution. And P naught, this is pure pressure. Okay. So we will fill the values directly here. So this is 480. Value of W1 is 150. And molar mass of the water is 18. Initial pressure is 24 and final is 23 and initial is 24 here. Multiply it, this will be 72,000 over 432 and final answer will be 166.6. So approx 167 gram. Okay, C is the correct answer of this question. Okay, so remaining questions we will discuss in the next video. If you want to give any feedback or if you have any query, you can write in the comment section and don't forget to like, share and subscribe because it motivates me a lot. Thank you.